When a drill press is used for metalworking, and there's a need to push the drill a bit harder on the workpiece at a higher speed, in most cases, the bit tends to overheat because of increased friction, and this can stop the drill from functioning properly. Now, there are several different ways to solve this problem. For instance, one solution might be to slow down the drill speed while pushing harder, because if the bit's RPM is too high, it tends to overheat as we discussed earlier. Keeping the drill bit sharp is another key factor. If you are using junk bits, keep a few spares handy and use a new one when you feel that it isn't cutting correctly. Another simple solution is to pour a mixture of water and soap on the workpiece and the bit when they get too hot. This solution keeps the drill bit cool most of the time. But a more professional solution would be to use cutting oil. The cutting oil can be placed in this container, and then this pump can suck it up and pour it on the bit and the workpiece. This can keep the bit cool and also lubricate the point of operation. You'll find cutting oil in about any Home Depot, Lowe's, Walmart, etc. Okay, as you can see, the drill press here has 3 switches that are connected to the IOO, IO1, and IO2 in sequence. IOO and IO1 are momentary start switches that are normally open, and IO2 is a momentary stop switch that is normally closed. We also have 2 outputs. The first one is for the drill motor and is connected to the Q4O output, and the second one is the pump, which is connected to the Q41. Now, we want to write a program for this machine that has the following features. When the IOO is pressed once, the drill motor should be turned on continually. When the IO1 is pressed once, this pump should be turned on to start pouring the cutting oil onto the bit and to the point of operation, but only on the condition that the drill is already turned on, because we don't want the pump to be turned on before the drill starts working. We want the program to operate in such a way that pressing the stop switch once causes both the drill and pump outputs to be shut down together immediately. Okay, after creating a new project and configuring the hardware, we're going to double-click on OB1 to start programming. We said that when the IOO is pressed, we want the drill to start working continually. So first, we put an open contact here for the IOO because it's a normally open switch. And then from the bit logic folder, we also put a set instruction here and give it the address of the drill. So with this instruction, when the IOO is pressed once, the output will be true. And because we've used the set instruction here, after removing our hand from the switch, the output stays true continually. Okay, we need a similar operation for the pump output too. So, in order to program a little faster, I'm going to copy this line of code and paste it here, and then change the input address to IO1, which is the address of the second start switch, and also change the output address to Q41, which is the address of the pump. Now, when the IO1 is pressed, the pump will be turned on continually, but we want to create a condition where the pump cannot be energized if the drill is not turned on yet. To do this, we need to put an open contact here before the IO1 and give it the address of the drill. Having done this, the IO1 is now working and can turn the pump on only when the drill output is true. We call this type of logic one after the other. This means, in our example case here, that the pump will only start working after the drill is turned on. Okay, we said that when the stop button is pressed, it should turn off both outputs simultaneously. So we need to add another network here, and then put a closed contact here, because the stop switch is a normally closed switch. Now, we need to put a reset instruction here and assign the address of the drill to it, so that when the stop switch is pressed, the drill is turned off. We want the same thing to happen for the pump too, so we make a branch here, add another reset output here, and enter Q41 for the address. So now, when the stop switch is pressed, both outputs will be reset and turned off. Now, let's save the program and download it to the CPU. Before testing the program, note this HMI station that has been added to our project tree. We need it because we're going to test our programs using WinCC Flexible in addition to the PLC simulator. But there's no need for you to use this station. Testing your program with the PLC simulator is enough. Okay, now we're going to put the program into online mode, and then, because the stop switch is a normally closed one, we're going to make the stop input true manually so that it can operate as a normally closed switch. At the moment, both the drill and the pump are turned off. Now, if we energize the I01, we see that its open contact is true, but because the drill is not energized yet and this contact is not closed yet, the pump won't actually turn on. Now, we press the I00 once, and as you can see, the drill output becomes true continually. So now, because this contact is already true, if we press I01 once again, the pump will be turned on and suck up the cutting oil to the bit. So, using the one after the other logic combined with this pump, we can prevent the drill bit from overheating when it's operating at higher speeds under pressure. Now when we press the stop switch once, we can see that both the drill and the pump are turned off simultaneously.